Welcome to lesson 1.3, describing quantitative data. What is the difference between X bar and mu? Take a sample of 15 AP students and ask them how many Snapchat streaks they have. Find the average number of streaks of this sample. That is the X bar notation for sample mean. Okay, use the sample to represent all AP students' Snapchat streaks. The parameter you are trying to measure is the true average mu of the notation for population mean number of Snapchat streaks for all AP students. So the key concepts here is that X bar is the sample mean, okay, but mu is the population mean. So the sample mean is only for the group that you gathered and that you actually have the data values for. And many times we have a sample that's going to hopefully stand in for an unknown population mean. Okay, and it's pronounced X bar. Mu is pronounced mu, M-E-W. The formula for X bar is the summation of all the observations over the total number in the sample size, and the notation just changes a little bit for mu, but the idea is still the same. The population mean is a summation of all the observations over capital N, the population. Okay? What is a resistant measure? Is the mean a resistant measure of center? Resistant measure of spread or resistant measure of center is referring to the fact that it's resistant to extreme observations. So resistant is just like an abbreviated version of saying resistant to extreme observations. So is it a feature, or it is a feature that is not influenced by outliers or skewness. Is mean a resistant measure of center? No, the mean is not a resistant measure of center. It is sensitive to extremes. So let's say that you had a group of children. One of them is 3, one of them's 4, one of them's 2, one of them's 5, and another one is 3 years old. And another one is 99 years old. Okay? Not a child. Okay. Find the average of their age. Well, that 99-year-old is going to jack up your average really high. You might have an average of, I'm just going to guess, like 15-year-old, right? But does that actually represent the average age of the students, of the children that you're describing? No. What was wrong with it? That 199-year-old really made that average way too high, okay? So if you have one extreme observation, it will pull the mean toward it, okay? It raised the mean up. 99 was a very high number. It raised the mean up to like 15-ish. Without it, your mean age of those children I just described might be like 3 years old, okay? 3.3 years old or something like that. All right, so extreme observations pull the mean toward it, okay? Meaning that if you have one very high or old person in a group of people and you are trying to find the mean age will be a little bit higher than, let's say, a median age, okay? That's because of that one older person. How can you estimate the mean of a histogram or a dot plot? Carefully count how many values are at each observation and turn them into data. So if you had a little histogram or a little dot plot like this, one person 4-year-old, 3 people 6-year-old, and 2 people 8-year-old, then you're going to have to add up all the people's ages, 4 and 6 and 6 and 6 and 8 and 8, and divide it by how many people you have, 6 people, and you get the mean age. Or if you're working on a histogram, you don't really know where the observation is. So maybe you're just going to guess that the observations are in the center of these bins, 0 to 100, 100 to 200, 200 to 300, 300 to 400. And maybe you're going to say you have like one observation at 50, 3 observations at 150, okay? Then 2 observations here and 2 observations there, and then divide it by how many observations you have in total. Okay, so it's not a real good science. Is the median a resistant measure of center? And explain, yes, because outliers and tails are X'd off and do not affect the center of the data. Median is the middle observation. So if you had your group of youngsters now, a 2-year-old, a 3, a 4, a 5, and another 3, and a 99-year-old. Okay. And if you found the median of their ages, well then you could put them in order And it actually doesn't matter if that 99-year-old was a 5-year-old or was a 99-year-old. We just know that they're the oldest. Okay, then you cross off these two, and your median would be 3.5. We take the average of the middle two. Okay, now if that person was just a 5-year-old, that wouldn't make a difference on median. And on mean, though, that would make a difference if that person lost, if we took off 94 years from that person's age. Okay, so mean is affected by extreme values, median is not. So we call it a resistant measure of center. All right, mean and median applet, the practice of statistics. Please go here and just play around a little bit with mean and median and pause this video here and check that out. Okay, all right. How does the shape of the distribution affect the relationship between mean and median? Home prices. This is a really common description. Okay, home prices and income are both extremely right-tailed. So that means that very few people own $500,000 homes, $750,000 homes, $1 million homes, $1.25 million homes, and so on, all the way up to 10 and 20 and 30 and $50 million homes. Okay, but many more people own somewhere between a $80,000 home and a $300,000 home. Okay, for roughly symmetric distributions, mean and median are roughly the same, but for skewed distributions, or for distributions with outliers, the mean is pulled towards the extreme values. This goes for upper tails or for lower tails, okay? The median will look like it's in the middle, but the mean will be pulled towards the tail, okay? What is the range? Is it a resistant measure of spread? And explain. Range is the constant distance between the maximum and minimum. Be sure to always represent this as a single value, not an interval. Range is not a resistant measure because min and max values are used, and they may be outliers. They may be extreme. Therefore, the range is affected by outliers. Okay, remember that range is only a distance between the max and min. So you take max minus minimum, and then you get the range, and the range is a constant, okay? All right, range is not an interval. We no longer say that the data ranges from 2 to 99. We say that the data has a range of 97. Okay, and that's the correct AP Stats way to discuss range. All right, what are quartiles? How do you find them? The first quartile, Q1, is the median of the data to the left of the median, and the third quartile, Q3, is the median of the data to the right of the median. So if you had this data set, 1, 1, 2, 2, 3, 3, 3, 3, 4, 5, 6, then you found median first, 1 and 6, 2 and 5, 2 and 4, 2 and 3, 3 and 3. There's your median. Block it off. And the first quartile is the median to the of the data to the left of the median. Now notice that it's the median of the data to the left of the median. It does not include the median itself. It's the median of the data to the left, so we want to get rid of the median and just look at the data to the left of it. Now find the median of that data, 1 and 3, 2 and 2. There's your Q1. Okay? Then the Q3 is the median of the data to the right of the median, so get rid of the median, look at all your data that's left. 3 and 6 go away, 3 and 5 go away, and you're left with 4. So that's your Q1 and your Q3. They're the first quartile and third quartile, okay? And they represent kind of like the 25% mark and the 75% mark, where median kind of represents the 50% mark, okay? What is the interquartile range? That's IQR. Since the IQR a resistant measure of spread, that means resistant to extreme observations. IQR, a constant, is Q3 minus Q1. IQR is resistant as a measure of spread because it ignores the smallest and largest 25% of values. So if you had some extreme tail or an extreme tail on that side, IQR will ignore it because it chops off the tails and it just looks for the 25% mark and the 75% mark. Okay, alternate example, McDonald's fish and chicken sandwiches. Here are data on the amount of fat in grams in 9 different McDonald's fish and chicken sandwiches. Calculate the median and the IQR. Here what I do is I take all the grams of fat and I list them in order because median and IQR need them to be listed in order. And then I'm going to find the median first, cross off out from the outsides on both sides, one at a time until you get to the median. After you get to the median, cover it up and look for the median of the left side, cover it up and look for the median of the right side. Okay? All right, so right in between 14 and 16, we get a Q1. In between 22 and 27, we get a Q3. So Q1, Q3, median, and IQR. Okay, you have to be able to find Q1 and Q3 in order to get your IQR. IQR is an interquartile range. Realize that range is just a constant now. It's not saying the data ranges from blank to blank. No, that is not what we say in AP Stats. We say it has a range of 6. It has a range of 5. A range of 9.5 grams of fat. Okay, what is an outlier? How do you identify them? Okay, an outlier is a data value that is more than 1.5 times IQR above Q3 or below Q1. Here's the data for the amount of fat for McDonald's beef sandwiches. Are there any outliers in this distribution? So here I do the beef distribution, list it out in order, find your median, find your Q1, your Q3. This is worth discussing. I'm going to go through the median real quick, even though I have it found. I just want to go through the process so you can see the process, so you can do the process later on. 9 and 43 go away, 12 and 31, 19 and 29, 23 and 29, 24 and 27, and you're left with 2 in the middle. Clearly, 26 is your median. It's the middle of 26 and 26. Now you're going to find your IQR by looking at the data to the left of the median. Realize that your median stuck out here like a little lollipop. Okay, so this 26 is to the left of the median. So that 26 is now eligible to start to be part of this left group. So 9 and that 26 are the first ones that cross off. 12 and 24, 19 and 23, 21, make a little popsicle stick with a little lollipop, okay? Same thing on the other side. That 26 and that 43 are the first ones that cross off. And then you get to 29. Okay, after you have your Q3 and Q1, you need to find your IQR, which is Q3 minus Q1, the interquartile range, okay? And that's 29 minus 21, which is 8. 1.5 times IQR is 1.5 times 8, which is 12. This is the 1.5 times IQR rule. You need to be 1.5 times the IQR above Q3 or below Q1. That's the cutoff for outliers, and it has to be more extreme than that. So I work on a number line now, and I find that 1.5 times IQR is a constant of 12. I'm going to take Q3. I'm going to take Q3 and add this constant to it. I'm going to take my 29 and add that 12 to it, and I get 41. 41 is the cutoff for outliers. Anything more extreme than 41 is an outlier. A value of 41 grams of fat itself is not an outlier. That means that 43, an observation that we had of a type of beef sandwich, oops, that's 24, 43, don't even see it right now. There it is, double quarter pounder with cheese. That one is an outlier for grams of fat. A high outlier, we could call it, because it's up this way on the number line. Okay, and then I need to still check to see if I have any low outliers. Okay, all right, so here we go. 1.5 times IQR, take it off of the Q1. So notice that I'm checking 1.5 times IQR above Q3 and below Q1. That's where I take my point of subtraction or addition. 21 minus that 12 is 9. 9 is my low cutoff. I do have a sandwich with exactly 9 grams of fat, but that's okay. I need that value to be more than 1.5 times IQR above or more than 1.5 times IQR below Q1, and it's not, okay? All right, it's not below that cutoff, so there are no low outliers. What is the 5-number summary and how is it displayed? The 5-number summary is the min, Q1, median, Q3, max. Okay, so in this group here, the 5-number summary is 9, 21, 26, 29, and 43. The min, those 3, and the max. Draw parallel box plots for the beef and chicken sandwich data. Compare these distributions. A 5-number summary is displayed as a box plot. Okay, here's how we do it. Stacked means side by side, means parallel. It means that you're using 2 different y-axes, but you're using the same x-axis for points of comparison. So, what do I have on this table? I have a title, I have labels, I have my box plots of data, I have an axis that is scaled and has consistent counting intervals, like tens, okay, and is as equally spaced as I have the talent to draw it. So I went ahead and I drew out the chicken and fish sandwich distribution, 9, 15, 19, 24.5, 33. Okay. And then the beef one, 9, 21, 26, 29, 43. But since 43 is an outlier, 43 gets a star. And I go back in observation to 31, and I only take the tail out to 31. So in the 5-number summary, we go min, Q1, median, Q3, max. But if a max or a min was an outlier, I make an asterisk instead, or a dot, whatever your artistic preference is. Put that out there instead, and I just list the other ones instead. Okay. Your calculator will also make these. So if you go to Stat, and if you go to Edit, and if you go up, clear, down, then it will clear a list for you. Don't hit delete, or that will actually get rid of the whole list completely, and you won't have an L1 anymore. Okay, I'm just going to show you real quick that information here. If I type this in, 9, 12, 19, 23, 24, 26, 26, 27, 29, 29, 31, 43, I mean to type in all of my data. I want to go stat, calc, 1 variable stats, and I want to pull from my L1. I don't need a frequency list. Well, here's a whole bunch of information. There's my mean, there's my standard deviation, population standard deviation, number of observations. Here's my 5-number summary by pressing down. Min is 9, Q1 is 21, median is 26, Q3 is 29, and max is 43. So what I'm going to do is go to stat plot, turn plot 1 on, and if any of these other ones are on, you're going to want to make sure you go ahead and turn them off. Okay, so go into plot 1, make sure it's on, go down to box plot, because you want to graph a box plot of this. Make sure you're pulling from L1, because that's where you put your list of data. Make sure your frequency is just the value 1, so that there's 1 of each of these data values. Okay, after that, oh sorry, you also want this box whisker plot, not the next one. You want this one because it has those distinct dots that are separate that mean that you're going to graph outliers as distinct dots, just like we wish to plot them as separate and distinct. Okay, after that, I'm going to go to second quit. I'm going to check this one area as well, because this could lead to a little bit of corruptions in your graphs. Make sure all of your Y's are blank. Okay, so go ahead and check them all out. Looks good to me. Second quit. Okay, I'd like to go to Zoom Stat. Stat is the 9th option down, so you can press 9 on your keyboard, or you can just scroll down to the 9th option. This means it's going to pull out of your Stat menu that list of numbers that you stored in there. Zoom Stat is going to get me a window then that shows my box whisker and my outlier, and it fits it all on one screen. Remember, the y-axis doesn't really mean anything, okay? It's the x-axis that means everything. Now, this is good and bad. What's bad about being able to graph it on your calculator is a tendency for students to think, well, great, I'm just going to copy that. Okay, but the issue with copying it is we actually have a lot less accuracy in copying it than we do in just creating our own unique box whisker plot. Okay, if I create my own box whisker plot from my 5-number summary, which sure, I could get that from my calculator, going stat calc 1 variable stats, Or I can get it by hand, okay, by using my fingers and counting outward and finding the median Q1 and Q3. Any way you get your 5-number summary is great. Use that 5-number summary to graph this box whisker plot and try to graph it with the most accuracy you can coming off of this wonderfully scaled number line axis, okay? You really want your box whisker plot to be accurate so that you get your points for this problem and so that it does not look like you copied it from a calculator. Your judges are very sensitive to that and really don't like students copying from a calculator. A common error is using IQR to describe the region, not the distance between the quartiles. Make sure that you talk about IQR as being a distance between quartiles, not as like a zone to refer to. The IQR area, okay, no, don't talk about IQR as if it's like a region. Talk about how to make a bot plot. Okay, I tried to. Okay, outliers often reveal interesting information provided that they are not mistakes. An example is this fascinating story about the discovery of the ozone hole in the atmosphere in Antarctica. Nimbus 7 satellite data were collected in the 1970s that would have shown unusually low ozone layers over Antarctica, but a NASA computer program included a filter that was designed to discard sudden, large drops in ozone concentration as errors. The phenomenon went unnoticed until an article in the May 1985 issue of Nature published summarized data collected by the British Antarctic Survey that showed the spring ozone levels had dropped to 10% below normal levels for Antarctica. After the article appeared, NASA reran the Nimbus 7 data without the filter program. Evidence of the ozone hole was then seen as far back as 1976. So here's a vivid example in which outliers were not the result of an instrument error, computation error, or recording error, but were, in fact, the message. It also dramatizes the need for the repetition of scientific experiments. On the other hand, an outlier may be an outlier simply due to a mistake by the person gathering the data or because the measuring instrument malfunctioned. Manhattan, Kansas is sometimes called the Little Apple to distinguish it from the other Manhattan. A few years ago, a house there appeared in the county's appraiser's records valued at $200 million. That would be quite a house even on Manhattan Island. As you might guess, the entry was wrong. The true value was $59,500. But before the error was discovered, the county, the city, and the school board had based their budgets on the total appraised value of real estate, which the one outlier jacked up by 6.5%. It can pay to spot outliers before you trust your data. Standard deviation. In the distribution below, how far are the values from the mean on average? So if I was to count up these values and say, well, I've got 3 on the left, 3 on the right, and my mean is right here in the middle, 4, then my standard deviation is actually 2.12. What does a standard deviation measure? Standard deviation measures the typical distance that the data's values vary from the mean. Okay. So I would have you guys go ahead and go into this, make some little data sets, and check your standard deviation. Okay. And try to guess what your standard deviation is. Okay. What are some similarities and differences between range, IQR, and standard deviation? Similarities. These are all measures of variability or spread. Differences. The ones that are resistant are IQR. Not resistant is range and standard deviation. Okay. IQR and range only use 2 points, but range uses the most outer 2 points, so it is of course affected by extreme data values. Standard deviation does account for all the points in the data set. Okay, how is standard deviation calculated? Calculate the standard deviation for the dot plot above. What is the variance? What is this distance between sigma x and Sx? Okay, so here's a copy of the data from the page before. And standard deviation is a summation of all of the difference of all the values and their difference from the mean of the data squared divided by the number of data in the data set. Okay, so the standard deviation of a sample, though, is divided by 1 less. Now, what we know about numbers is that if we make a denominator smaller, then we make the overall value bigger. Okay, so standard deviation of a sample, it has a little bit more, is a tiny bit bigger, and that's just to add for a little bit more flexibility around the fact that we don't have every data value, and this is always a constant of 1. Okay, so what we do is we start by taking each observation, subtracting it from the mean, and then we square that. And in a way, we're starting right here in the center, each observation's difference from mean, and squaring it. Then we find the sum of all those values. Okay, I'm just not showing my work. 2 minus 4 is -2, and then squared is 4. And 3 minus 4 is -1, squared is 1. And then, so these are all the squared differences from the mean. Now you can tell that squared differences of the mean that are of values that are close to the mean, like 3 and 5 that are on either side of the mean of 4, that they don't have a big impact on the size of the standard deviation. But values that are much further away have a much bigger impact because of that squaring on the size of the standard deviation. Now the next step is to take that summation of all of the values differences from the mean and to divide by how many values you have. Now say this is a sample, so I'd be working with n minus 1, which is 8 minus 1, which is 7. So 36 divided by 7 is 5.14, square root of 5.14 is 2.12, okay? Or the other version, if you did the population, it's 2.267. Remember the formulas on the formula sheet. You don't really need to worry about the variance. Now it's just standard deviation squared. Okay, okay, very good. What are some properties for the standard deviation? Sx is only used when mean is used to measure center. Sx is always greater than or equal to 0. A special case, Sx equals 0 if there's absolutely no variability, so if your graph has just a single stack of points, okay, and there's none to the left or none to the right, then each point's difference from the mean subtracts to give you 0, because each point is equal to the mean. So two values that are equal to each other, when you subtract them, you get 0, square it, you get 0. So summation at the top would be a summation of a whole bunch of zeros added up, which is 0, divided by anything is 0, 0 square rooted is 0. Okay, where were we? Oh, okay. Sx is the same unit of measure as the original observations. So the standard deviation of fat is still written in grams. Sx is not a resistant measure of spread. Outliers make it very large, okay? So if you had a really extreme data value here that's really far from the mean, it's going to really increase the value listed here then when it's subtracted from the mean, so it's distance from the mean, and then it's going to square and have a really large value and a high impact on the standard deviation. Arguable is the fact that if you added another value to the list, that the mean value will go up as well. And that's true, but it is one value raising the value of the mean, and the mean is kind of weighted, and it still takes into effect all these other values here. So true, your mean will change if you added a number like 99 to this list, but still 99's difference from the new mean will still be such a great value. It'll be much bigger when it's squared than 9's, 4's, and 1's are. Okay. A random sample of 5 students was asked how many minutes they spent doing homework the previous night. Here are their responses in minutes. Calculate and interpret the standard deviation. There are a couple keywords in here. This is a sample of 5 students, so I now know that I'm using the n-1 formula and that I'm using Sx and x bar in my notation, meaning that it's the sample standard deviation I'm looking for and it's a sample mean that I'm subtracting from. So each observation listed here, and I found the mean to be 41 minutes. So I'm going to subtract from 41, 0 minus 41, 25 minus 41, 30, 60, and 90 minus 41. Okay, next I square all these values, sum them up, and now I'm here. The summation of each value's difference from the mean squared. Okay, divide by n-1. There are 5 students that I took and asked their homework time in minutes. And so I take n minus 1, 5 minus 1 is 4. And then I divide that, and I get 1205. Sorry, sloppy, 1205. And then square root that, 34.7. Okay, calculate, did it, interpret. The number of minutes a student spends on homework typically varies from the mean of 41 minutes by about 34.7 minutes on average. This is a good template to memorize for interpreting standard deviation. The typical context varies from the mean by about the standard deviation on average. Okay. What factors should you consider when choosing summary statistics? Consider the shape. If the shape is symmetric, bell-shaped, or uniform, use mean and standard deviation. If the shape is skewed, has outliers, or is multimodal or bimodal, use median and IQR. 2, consider the context. Is it a little bit skewed, but in general, you know that if there was more data there, that the distribution would be symmetric. Also include some evidence, about why the shape is the way it is, okay? Matching distributions activity, okay, great. So that is it, okay. So when you interpret standard deviation, I would do it something like this. The typical amount of time a student spends on their homework varies from the mean number of minutes a typical student spends on their homework Okay. The typical number of minutes a student spends doing their homework each night varies from the mean number of minutes of 41 minutes by about whatever number of minutes that was, 34.7 minutes per night. Okay? And that's right here. Oops, sorry. That's important. Okay, sorry about that. Okay. All right, very good now. That looks better. All right, folks, thank you for joining. Good luck.